This video is about angles of a triangle. You can find it in your text in section 3-4. First of all, a little bit of vocabulary and notation. We have a triangle here, and we call this triangle ABC. It's named after its three vertices, and the notation that we use for shorthand is just to make a little triangle, and we read this triangle ABC. This triangle, every triangle has three vertices, and vertices are points. So the three vertices here are simply point A, point B, and point C. The sides of a triangle are line segments. So we would name the sides of this triangle segment AB, segment BC, and segment AC. The angles of a triangle we name in the way that we ordinarily name angles. So in this case, since this is a very simple diagram and each angle only has, each B is the vertex of only one angle, we could simply call this angle B. So the three angles of this triangle are angle A, angle B, and angle C. Now, we have different names for different kinds of triangles. In this chart, which I'm going to give you more time to copy in a minute, I made the green section refer to names that are talking about the sides of a triangle and the relationship between those sides. In the gray section of the chart, I have names that we give triangles based on the relationships between their angles, or actually just the type of angles that they have. So a scalene triangle has no sides congruent, and this is a picture of how that might look. An isosceles triangle has at least two sides congruent. So we have this side and this side congruent in this triangle. An equilateral triangle has all three sides congruent. So in this diagram, I could mark all three of these sides congruent. Now an acute triangle has three acute angles, and I'm going to let you draw a picture of an acute triangle in this chart. An obtuse triangle has one obtuse angle. Think for a minute about why a triangle couldn't possibly have more than one obtuse angle. A right triangle has one right angle, and again, think about whether a triangle could have more than one right angle. An equiangular triangle has all of its angles congruent. We don't use this word very often, and I'll give you a hint. An equiangular triangle is the same kind of triangle as one of these three up here. So take a minute to finish filling in this chart before you continue. The angle sum theorem says that the sum of the measures of the angles of a triangle is 180 degrees. So in this case, we have measure of angle A plus measure of angle B plus measure of angle C equals 180 degrees. The exterior angle theorem might be a little more unfamiliar to you. It says the measure of an exterior angle of a triangle equals the sum of the measures of the two remote interior angles. So an exterior angle is formed when we extend one of the sides of the triangle and we look at the angle that's outside of the triangle along that same line or ray. The remote interior angles, the word remote can remind you that they have to be far away from this exterior angle. In this case, the remote interior angles are angle B and angle C. So the exterior angle theorem, if we were to make a point here called D, would tell us that the measure of angle DAB equals the measure of angle plus the measure of angle C. Let's do an example problem. Suppose the measure of angle 6 is x. The measure of angle 7 is, I'm going to make an arrow here, x minus 20. And the measure of angle 11 is 80 degrees. And we're asked to find x. Well, the exterior angle theorem tells me that the measure of angle 11, which is an exterior angle, must equal the measure of angle 6 plus the measure of angle 7, which are the two remote interior angles here. So I'm going to put in values for these. The measure of angle 11 is 80. The measure of angle 6, we're told, is x. The measure of angle 7, we're told, is x minus 20. And then we can use algebra to solve for x. 80 equals 2x minus 20. Adding 20 to both sides, 100 equals 2x. Dividing both sides by 2, 50 equals x. And since we're talking about angles, we'll say 50 degrees. Now you try one. Suppose the measure of angle 9 plus the measure of angle 10 plus the measure of angle 11 are all added up. What would that have to equal? Let's do another example. Suppose we're asked to find the values of x and y in this diagram. Well, again, we can use the exterior angle theorem, noticing that angle x is exterior to this triangle here. So the exterior angle theorem tells us that x must equal the 65 degrees plus 25 degrees, the two remote interior angles. And those would add up to 90 degrees. And in the diagram, this doesn't look like a right angle, but we have to trust our math and the exterior angle theorem and believe that it is, because we've just solved for it. Now, to solve for y, we can notice that there's another triangle here, which might be a little hard to see at first. But it's this triangle here. And since we have the perpendicular angles theorem, perpendicular lines theorem, we know that this is also a right angle here. And now we have this triangle, the measures summing to 180 degrees. So we have 65 degrees plus 90 degrees plus whatever y is must add up to 180 degrees. So again, here it's pretty easy to solve using algebra. We can subtract 65 plus 90 from both sides. And we get that y equals 25 degrees. So now we've solved for x and y. You try one. Find the values of x and y using this diagram. For further practice, see page 97 in your text, numbers 1 to 15 odd.